Good morning, wonderful students. You are welcome to today's episode on mathematics. Our topic still remains linear sequences or sequences in arithmetic progression. In our previous episode, we discussed about what a linear sequence is, and we also observed that it is very, very simple for us to form a linear sequence or a sequence in arithmetic progression by simply what? By simply inserting arithmetic means in between the numbers. That if you are given two numbers, if you want to form a sequence in arithmetic progression without two numbers, what you simply do is what? You insert what? Arithmetic means in between the numbers. By inserting this arithmetic means in between the numbers, you are actually forming a sequence in what? In arithmetic what? Progression. That we saw and solve problems in it in our last episode. So we have equally seen that if you are given any two numbers, it is possible for us to insert as many arithmetic means as we wish in between these numbers, so as to enable us to form a sequence in what? In arithmetic what? Progression. But what we are saying is that these numbers, is there any restriction to the type of numbers that can be used to form arithmetic means? Is there any restriction to the type of number that can be used to form a sequence in arithmetic progression by inserting means in between them? The answer to that question is no. Any number can be used, any two numbers given to you can be used to form a sequence in arithmetic progression by inserting means in between them, irrespective of the type of number given to you. Even if the number given to you is a real number, if it is a rational number, if it is an integer, a whole number, or even a natural number, this assumption still holds. So the question we are here to solve this morning dwells on this. It takes care of this problem, that it is possible to insert arithmetic means in between any type of number given to you. So here we are asked a question. You can see the question we have on the board. The question simply reads that what? That we should insert 4 arithmetic means between the number, the unknown number. This number is an unknown number. We don't know what x is. We don't know what y is. So therefore, this number is unknown. This number can be a real number. It can be an integer, a whole number. It can even be a what? Natural number. It can even be a rational number. When I talk about rational numbers, I mean what? I mean fractions. In the same vein, look at this. So the two numbers, they are what? They are unknown numbers. They can be any type of number. So we want to insert what? We want to insert 4 arithmetic means in between these two numbers. All right? Then, of course, we have equally seen that once you insert arithmetic means in between two numbers, that you will definitely form a sequence in what? Arithmetic what? Progression. So, of course, the means I want to insert in between these two numbers, I don't know them. So I have to make an assumption of what the means would there be. Or maybe instead of making an assumption, I can just use a letter or a symbol to represent the unknown means. So I can just say solution. I can say let the what? Let the 4 arithmetic means be the what? Be M1, M2, M3, and M4. Such that, of course, such that when I insert these 4 means in between these two numbers, I will now form a sequence in arithmetic what? Progression. What I mean is that the first number x plus 3y, comma, insert the first mean M1, comma, insert the second mean M2, comma, insert the third mean M3, comma, insert the fourth mean M4, then comma, we now have the last number x minus 3y. Forms a sequence in arithmetic what? Progression. And if this is a sequence in arithmetic progression, it means that this sequence contains how many terms? 1, 2, 3, 4, 5, 6. It contains 6 terms. It contains what? 6 what? Terms. Now, among the terms of this sequence, you can observe that the first term is given as x plus what? 3y. And the last term is given as what? X minus 3 what? 3y. So therefore, we can name the sequences. Of course, we can name the terms of this sequence as, this implies that our first term A from this sequence is equals to x plus 3y. The second term, which is normally written as t sub 2, is equals to the first mean. And the third term, which is equals to t sub 3, is equals to the what? The second mean. And the fourth term, t sub 4, is equal to the third mean. And then the fifth term, t sub 5, is equals to the what? The fourth mean. Whereby the sixth term, t sub 6, is given as what? As x minus 3y. So with all these things, we can now start our solving. But I am looking for the means, MO1, MO2, MO3, and MO4, which happens to be the second term, the third term, and the fourth term, and the fifth term. But remember that the terms of a sequence, in arithmetic progression can never be found unless the first term and the what and the common difference is known. That is what I'm saying is that if one claims that this sequence of numbers is in arithmetic progression, that simply means that I am saying that what? That there exists a common difference between any two consecutive terms of this sequence. That's what the statement says. If you say that this sequence is in arithmetic progression, it means that you are actually convincing us or telling us that what? That there exists a common what? Difference between any two consecutive terms of this sequence. But that common difference, we don't know it yet. We don't know the value of the common difference. So therefore, we have to find it. Even if we cannot find it, we must find an expression that can represent it. So from this point, or from this note, we are given the sixth term as this. So we know the sixth term as this. So what from there? So now, all right, let me clean up this part of the board. All right, so now the sixth term, t sub 6, was given to us from the question as what? As x minus 3y. But remember that this sequence is in arithmetic progression, which means that the sixth term can be represented by the expression a plus 5d. We are already aware of this. And the value is equals to x minus 3 what? Y, unknown, which can be any number. But the first term is known to us. It was given. First term is given as x plus 3y. So now it means that anywhere I see my a, I put x plus 3y. So this means x plus 3y plus 5d is equals to x minus 3y. What are we looking for? We are looking for the common difference. We are looking for the common what? Difference. That is why we are starting from this point. Because the sixth term is known. And the what? And the first term is given. So in mathematics, we always work from the known to the what? To the unknowns. All these things here are the unknowns. MO1, MO2, MO3, MO4, they are the unknowns. But this one, t sub 6 is known. And then the first term A is also what? Given. So of course, this now implies that if I continue with my working, so I have to do the working. So this guys will come to this side. This means that 5d alone will be equals to x minus 3y. Then I have minus x minus 3y. And if I resolve this clearly, it means that 5d will be equals to what? I hope you can see this. So this means that 5d will be equals to, now our x minus x gives us 0. This goes with this. And then this minus 3 gives us minus 6. So this gives us minus 6y. So that implies that the common difference d is equals to minus 6 over 5y. So this is the value of the common difference. Now we know the value of the common difference. And we know the value of the first term as this. We can now proceed to find the terms of the sequence. Because if you take notes, we said at the beginning part of this our episode of this lecture that immediately the first term and the common difference of a sequence in arithmetic progression is known, then any of the terms of the sequence can be what? Can be found. So now, since I now know the common difference and the first term, I can now find all these other terms which represent the means that is being inserted in between these numbers. So now I proceed in the same approach. So now, I want to find the first mean, M1, which happens to be the what? Which happens to be the second term. So, next, consider the first mean M1 which happens to be the second term of that sequence in AP. Of course, that now implies that our M1 will be equals to the second term of any sequence in AP has a representation given as A plus D. And this now means that what? This means that the first mean M1 will be equals to, what is my A? My A is x plus 3y. So this means x plus 3y for A. Then I have plus D. Is D given? Look at the value of D there. D is equals to what? Minus 6 over 5. Y. And we all know why I am putting this bracket, because you can see D is bearing a negative sign and I have plus here. When you see two signs occurring in mathematics, what you do is what? You separate them using what? Parentheses. Okay, so of course, this now implies that what? That okay, let me write here. This now implies that the first mean M1 will equals to x plus 3y plus times minus gives us minus, and we'll have 6 over 5y. And this means that M1 will be equals to x. Now, when we now resolve this, we have to resolve that. That is 3 minus 6 over 5. That will give us, this is 15. 15 minus this will give us what? 9. Okay, 3 minus 6 over 5. That's 9 over 5. That gives us plus 9 over 5y. So this will be the value of the what? Of the first mean. So in the same vein, in the same way, similarly, the second mean M2 was given as what? T3, isn't it? Yes, it was given as T3. That's the third term. So this now means that the second mean M2 will be equals to third term for any sequence in AP is given as A plus 2D. So this means that the second mean M2 will be equals to, what is the value of my A? My A is given as what? As x plus 3y plus 2 into bracket. What is the value of my D? My D I have as minus 6 over 5y. So this input equally means that what? That the M2, the second mean, is simply equals to x plus 3y minus, because plus times minus gives us minus. Then 2 times 6 gives us what? 12. We have over 5. We have y here. So we can resolve this. This times this is 15. 15 minus 12 will give us what? 3. So this simply means that M2 will be equals to x what? X plus, what I had again? 15 minus this is what? 3. So I have 15 minus, yes, 3. Over 5, 1. So this is the value of the second mean. We can equally find the third mean. To find the third mean, we use that the third mean M2, or M3, sorry. Now, next, the third mean M3 will be equals to what? The fourth term. Which means that the third mean M3 will be equals to A plus what? 3 what? D. Now, resolving this in the same approach, or the same manner, we can then see, let me clean up this side. Resolving this, we now have that the third mean M3, this means that the third mean M3 will be equals to A plus what? 3 what? 3D. Which means that the third mean M3 is equals to, what is my A? My A is x plus what? 3y. Plus 3 into, what is my D? Minus 6 over 5y. So this simply means that M3 will be equals to x plus 3y plus times minus, minus 6 times 8, 3 times 6 will give us what? 18 over 5y. So this simply means that M3 will be equals to x. This times this will give us 15. 15 minus this gives us minus 3 over 5y. So this is the value of the third mean. Now I believe that you can equally find the fourth mean by using the same approach. And it is clear because finally, the fourth mean, M4, from the expression we had, it was given as is equals to the fifth term of that sequence in arithmetic progression. So which means that what? That now means that the fourth mean, M4, will be equals to the fifth term of any sequence in AP is normally given as what? A plus what? 4D. So that simply means that the fourth mean, M4, will be equals to, what's my A? My A is x plus what? 3y. Then plus 4 into, what is my D? My D is minus 6 over 5y. So this simply means that the fourth mean will be equals to x plus 3y plus times minus 4 times 6 is 24 over 5y. And that simply implies that our M4 will be equals to x 3 by 5 is what? 15. 15 minus 24 gives us what? 15 minus 24 gives us minus 9. So this is just minus 9 over 5y. So this is the value of the mean. So I have my M1. My M1 is what? I got my M1 and this is my M2. My M2 I solved is what? X plus this. M3 we solved and got this. Then M4 we have solved and we got this. So you can see that we have been able to find the means that can be inserted in between the unknown number x plus 3y and the unknown number x minus 3y, so as to form a sequence in what? In arithmetic what? Progression. Now we are going to move to the next topic. The next topic now is discussing about geometric sequences, that is exponential sequences. In exponential sequences now, we're going to look at what? The relationship between geometric sequences and what? And the geometric means. Remember I told you that we have different types of means in mathematics. The simplest among them is the arithmetic mean. The what? Arithmetic what? Mean. The next one is the one we call the geometric mean. We also have what we call the harmonic means and the what? And the weighted means. So in the next episode we are going to look at the possibility, if you are given two numbers. Now, this episode of our lecture has convinced us that once you are given two numbers, that it is possible for you to insert as many arithmetic means as you wish in between that two numbers. And when you carry out that particular operation of inserting arithmetic means in between two numbers, you will simply form a sequence in what? Arithmetic what? Progression. In the same vein, if you are given two numbers, the same type of numbers, or any number at all, it is also possible for you to insert as many geometric means as you wish in between the numbers. But in this case now, when you insert geometric means in between two numbers, you are going to form a sequence in what? In geometric what? Progression. That is what we are going to look at in the next episode of our lecture. So continue subscribing and keep on watching more of our video lectures as we move to the next episode of our lecture. Thank you.